two lines are perpendicular if they meet at right angles, and we use this notation to indicate that the lines L1 and L2 are perpendicular. If two lines are perpendicular, then the product of their slopes is -1, or m1 equals -1 over m2, and vice versa. If I have two lines where the product of the slopes is -1, then I can conclude that the lines are perpendicular. Suppose I want to show that two lines are perpendicular, then all I have to do is show that the product of the slopes is -1. So for these two lines here, let's call this one L1 and this one L2. To show that they're perpendicular, I just have to find the two slopes and show that the product is -1. I'm going to put this one in slope-intercept form. And I get its slope is -1/2. And for this one, I get y equals 2x minus 6, so its slope is 2. And when I take the product, m1 times m2, I get -1/2 times 2, which is -1. Therefore, L1 is perpendicular to L2, and that's what I had to show. Given a point on a line, and the equation of a line which is perpendicular to it, then I can figure out the equation of the line in question, because I can find its slope from the slope of the perpendicular line. So here I need to find the equation of a line, I'm going to call it L1, which runs through 0, 1, and so that L1 is perpendicular to L2, where L2 is the graph of x plus 2y equals 1. I need the slope of L1 in order to use my equation for the equation of a line with running through the point P here with slope m. So I need the slope of L1, and I know that, let's call this slope m1. m1 times m2 equals -1, or m1 equals -1 over m2, where m2 equals the slope of L2. What's the slope of L2? Well, I put L2 in slope-intercept form. I get 2y equals 1 minus x, or y equals 1/2 minus x over 2. So m2 is equal to -1/2. Now I have m1 is -1 over m2, which is -1 over -1/2, which is 2. And now L1 runs through 0, 1 with slope m1 equals 2. So the equation of L1 is, this is x1, y1, y minus y1 equals m1 times x minus x1. So I get y minus 1 equals 2 times x, or y equals 2x plus 1. And that's my answer.